0.
Hello everyone, and welcome to part 5 of the MS Masterclass, Creating and Sharing User EI and MSMS Libraries. Parts 1, 2, 3, and 4 are now available on demand for you to view at any time. Parts 1 and 3 have been re-recorded for quality purposes. During this session, James will reference his website and the session handouts, both of which you could find in the Resources tab on the right-hand side of your screen under A Little Mass Spec and Sailing. There you could also find the links to the other sessions in this series. Please feel free to submit your own questions at any time through the Ask a Question chat box, and James will address them via the email at the conclusion of the event. And now I'll hand it over to James to begin today's session.
Thank you very much, Ryan. I've really enjoyed doing this series with Wiley and sharing it with you. The last one is, like he said, part 5. And it's creating and sharing user EI and MS libraries. My name is James Little, and I live in Kingsport, Tennessee. I'm a retired research fellow from Eastman Chemical Company. I have 42 years experience in unknown identification, primarily with GCMS, but many other techniques. I'm now a consultant for MS Interpretation Services. It is my own company, and I'm the only employee. I have a lot of other specialties that I developed in support of my GCMS and LCMS work, and I list them on my webpage, and they're referenced at the end of this talk and on my webpage, and in the link that Ryan alluded to. Eastman Chemical Company is a large chemical company, the biggest site, probably around 7,000. I don't really know the current count of the 14,500 employees total work at the highly integrated plant in Kingsport, Tennessee. And this is the picture of it above. But there are 50 other manufacturing sites worldwide, and we make a wide variety of products. We've done 5 sessions when we finished this one. The first one was on spectral searches. The second one was on structure searches, AMDAS for deconvolution of EI mass spectral data to send to NIST for searching was the third one, from chromatographic data. The fourth one was what I think is a very exciting area, advanced NIST hybrid search, a new search that greatly expands the capabilities of the library without really adding any entries. And the final one today will be creating and sharing user EI and MSMS libraries. And I really didn't have enough time to talk about the MSMS libraries. The process is very similar. You might have to add some different tags to make it work properly. So I will just talk about the EI today. The handouts for all the sessions are online now, and you can find it at the reference at the end of the paper or at the end of the talk that's referenced on the side of the slides or on the side of this webcast there. But it's also, you can search Little Mass Spec and Sailing, and that should bring me right to the top. When I first did the sessions, I did not have a table of contents for the handouts, and I started looking at them, and they've gotten a little long, so it makes it a little difficult to find things in there. So I decided to go and recreate all the handouts and put table of contents that reference the slides to them. And I hope that'll make it easier for you to access the information. There are lots of help files for the NIST search and for AMDAS and for creating user libraries, etc. And you can find it in their manuals. You can find it on my website. You can also find additional information on my website. So take advantage of that. And Wiley also has a user manual for their database also. There's a lot of Windows compliant things that apply to the NIST software, which is good. So anything that you know about in Windows usually applies in the NIST software. One we'll be talking about today, and this is the one I use a lot, is this left mouse button on the first item and last item to select a group. We'll use that to filter out some ions in a spectrum, but it's good for sending things to different windows, for copying things in to make your own personal library, etc. So it's a very handy command. The other thing is you can sort things in a column after you do a search. Like if you do a search and you show up 955 out of 1,000, but all of a sudden you want to sort by reverse match, you just click on it again. You don't have to go and do a reverse match search. It just resorts the data for you. So let's go into a live demonstration of the software. That's the most important part of what I'll do today. And let's get the NIST search up. I guess Ryan will tell me if it didn't go over, but I think you should be seeing the NIST search now. But we're going to even go back a step further. We're going to AMDAS. let's pretend that someone submitted a sample that they want to consider for adding to our corporate database so that we'll have a record of it for lots of different reasons that we'll talk about later. But the first thing you need to do is open the file. And of course, I told you in AMDIS, the first thing you have to do is run it because it has to deconvolute the file before you can send any spectra to the NIST for searching. So it's deconvoluting it. And I just wanted to re-emphasize that often when you bring up AMDIS in its basic default settings, you get overmarking of peaks. You get a lot more peaks marked than you're interested in. So what you need to do is go up to the top, Analyze. You need to go to Settings. And the easiest way I find to filter a lot of things is go to the Filter tab. First thing you need to do is maybe reset all your things. So go to Deconvolution, set the default, go to the filter, set the default, and that gets you back to where you know you're at, because they don't really have a way to save the settings in AMDIS directly. And then just click on Enable Filters, and that usually cleans it up a lot, and say Save. It'll say you need to rerun it because you've changed the settings. You notice when we get through now, it's only marked 2 components. We'll expand it a little bit here. And we got a very good spectra at the bottom. Click on the little arrow at the top to get the deconvoluted. At the bottom, we have the white, which is the spectrum, and the black, which is the uncorrected spectrum. You can see there's very little background here. So we'll right-click on that and say Send, go to Mass Spec Program. It'll automatically come into focus and search it. So we have our spectrum for consideration up here. You can see it has some information, but you see what's lacking mainly is it searched the library and said, oh, it's not there. The best thing, if you see down below, is 500 out of 1,000, which means there's nothing really there. It's a lot of indication that it's consistent, but it's not in the database. So now we're ready to add it, but we need to get a structure associated with the spectrum. So we go open our drawing program and draw it. For my convenience, I've already drawn it just to save a little time. You select it, say Copy. That puts it in the Windows clipboard. Now we're ready to go back to the NIST search. And what we need to do is associate it with the spectrum. But how you do that is come all the way to the bottom and go over to another function on the bottom called the librarian. We go to the librarian here and we get ready. All we need to do is go to the Edit Spectrum. That opens it, that allows us to put the structure with the spectrum. So all we do is say From Clipboard, because it's already in the Windows clipboard, and the sad face will become a happy face and we'll have a structure. You can go up to the From Structure button up here, and you can calculate the molecular weight and the molecular formula automatically. So you don't have to scratch it on a piece of paper to figure it out. It just calculates it for you. And there it is, 313 molecular formula, consistent with the structure that we've drawn, of course. That's where it got it from. But we're not going to add it to the library initially. We want to add it to our list so we can just look at it a little bit. We want to make sure it's a good spectrum of what the chemist proposed. We're going to say Add to List. That'll add it to the spec list. Now, if we go to the bottom here and go back to the main tab, the lib search, come up to the top and you can see the #1 entry now is this compound with its associated structure added for us. So now we're good to go. We can take a look at it and see what we think. Well, the first thing I like to do to check for quality is, of course, search to see if it's in the library, which we already did. It's not. The other thing I would like to do is to make sure that this structure is not already in the library, because sometimes there'll be a structure in the library, but it's the wrong spectrum, or this is the wrong spectrum for our structure. So we want to search it by exact structure and make sure that structure is not in the database. And if you'll remember, to do an exact structured search, you need to go over and click Inchy key. And you can look back, I think that was in session 2 about our structure searches on how to do that and why you do that. You say okay, and then you say go. And it's really a library search because Inchy keys are associated with libraries. It's not a structure search per se. And you can see there was nothing found. That's good. It means it's not in the library. So we've done an exact structure search and it's not there. So that's good. No one else has seen it and it doesn't interfere with anything we plan on doing. The other thing you need to do is select it. So I selected it, left mouse button on the top entry. I need to right click and say Send to MS Interpreter. Okay, so now we have MS Interpreter up. If you'll remember, what it shows when it comes in, it always shows you the base peak. And so it tells you the base peak is this part here up to the benzyl group. It shows you the isotope ratios at 187. If you look at the little yellow bars, it tells you those are good, that they're consistent with the theoretical for that partial structure. You can see what our chemists like to say, everything's in black. So that's good news. If the majority of it's in black, MS Interpreter can explain it. If it's in yellow, it can explain it maybe by a multi-process reaction. If it's in white, it probably doesn't know what it is. So this looks like a really good possibility. I'm just going to do one other thing. Like you could check all of the fragments and see if they make logical sense to you as a chemist. And it looks good. That's loss of bromine. The other thing I like to check is the isotope ratio for the molecular ion. So I select it. You can see when I click on the little bars above the top for the 313, it shows the whole structure. That's the molecular ion. If you want to see how that shows up, then you send it to the isotope calculator. And I'll bring the isotope calculator window up, make it a little bigger here. You have to set up the settings correctly, and that was in our session 2. So I'll just do that real quickly. We won't go through why. You can see the colored part is the theoretical, and the other part, the black part, is the actual. And I've selected M-1, use M-1, because this isotope pattern is somewhat convoluted by the presence of a -1 loss of hydrogen to give its own isotope pattern that overlaps the molecular ion, but it takes that into consideration, perfect match. So we're good to go with that. So we're real happy that this compound is probably exactly what we want to put in the library. So I think we're good to go and put it in the library now. So let's go back to our library window. Okay, we're back. So we're ready to add it to the library now. So what do we need to do? Well, there's one other thing that I wanted to show you here. I'm not too bothered by this, but the one I'm going to add is here. If you want to get rid of an ion for some reason, let's say you thought the 29 and the 33 ion are not part of the spectrum. A lot of times you'll have 18 for water, 17 ion that goes with it, 28 and 32. Let's say you wanted to get rid of some small ions that you know, like silicone bleed. I don't really have any bleed here, but I just want to show you how to get rid of something just to show you. So what you do is you select what you want with the left mouse button. I'm going to hold the control key because I want to do, let's say 29, 33, and 38, and I want to make them go away before I add them to the library because I think they're chemical noise of some type. Well, if you do that, there's really no delete key on the window anywhere. So to do that, you have to select the delete key on your keyboard and push it. Now it goes away. So now those ions are gone away. But in this case, I didn't really want to get rid of them because they're not chemical noise, but I wanted to show you how to edit your spectrum to get rid of chemical noise if you couldn't get it all by deconvolution. So let's go back and go to our spectrum we want to add now. So we're good. This one might have a little nitrogen in it at the 28, so maybe we'll get rid of it. We'll go in and edit that. Let's get rid of the 28 ion. We'll delete that. And that might just be a little bit of nitrogen left over in the spectrum. So we'll just get rid of that. So now what we need to do is add it to the library. Okay, so the first thing you want to do is maybe put in some other names because we have common names for a lot of our chemicals. Let's call this stabilizer 123. We'll put a return. Let's call it Xanthol impurity. Anything that's useful to you, you can put there. All right, usually I put a lot of different comments on where it came from. And that can, if you're going to do it for about 10 components in a chromatogram, let's say I'm going to add 10 things out of this file, that gets to be a little old after a while. So what I do is I use Notepad and I create exactly what I want to put in each one of them and put it in Notepad and just say copy. And when I copy that, I can go and put it in comments and paste it. And it automatically comes in, so you don't have to type it every time now. And so all we need to do now is add this to the library because we're in good shape. We've got all the comments we want in there. We got the molecular weight. We've got some common names. So we want to say to add to library. And we go over to the library and let's call it new library. We call it new library 1. And so all you have to do, if you wanted to select a current previous library, you just pick it. But will be the first time I'll create it. So I'll just call it new library 1. And that. We'll say OK. And say add to library. And it added it. So we're good. Now it's in a library and we have a new library 1. The only problem is that the first time you create a library, you don't have all the indices you need. So you need to use the NIST search to do that. So you come over to options, tools, and you say, before it'll do a structure search on this library, you have to rebuild the structure search database. And that happens when you add a new spectrum to a database also. You have to also do that. But the first time you have to create it. You might want to create the hybrid search index for it. And the other thing you'll need to create if you want to do an exact search would be index the inchy key. So those are things that you need to do. And when you pick one, let's just do one of them. The inchy key, you'll find that our library doesn't show up because the program doesn't know it's there yet. There's one other thing you need to do. You need to go to Tools and let's say update the list of the libraries. And what it does is it goes out on the disk drive and looks for any new libraries you just created so it can bring them in. You could have exited the program and come back in. It would have found it when it goes out and looks in its directory when it first turns the program on. But if you don't want to do that, always just go and say update the list of the libraries. Now let's re-index our inchy key. And you'll come down and you'll see it should be there somewhere. No, there first time. And just say, OK. And now the inchy key index is updated. So everything's in good shape now. So we've essentially added it to the library. We searched to make sure it's good. We've made it so it's searchable. So that's pretty much everything you need to do. We showed how to get rid of background. We added to a new library, updated the indices. So we're good. Everything's ready to go. So that's pretty much the whole thing about creating a user library and adding a spectrum. It's really not very hard to do at all after you get used to the process and plus the other things we've learned in the other parts of the seminar. So let's go back to this software and talk about a couple of other things, back to the presentation, the PowerPoint. The other thing I want to talk about is tags. When I added mine, I just said who the chemist was and the background information that was identified, confirmed by chemical ionization, etc. But the other thing you can do is you can put tags in. So you put it in a little bit more of a formal way. So you say chemist equals John White, and your tag will be chemist. That'll be your label that'll show up in the library entry. And I did it for lab notebook here. I created another analyst one for who put it in. Anything that's not in the quotes, this will be left over in the comment when it's through. So I'll show you what it does. But when it shows up, they'll show up as separate lines in the library entry. And anything that was shown as a tag will be removed from the total comment. But the first thing you have to do is you have to go up to the menu and say options, and you have to tell the system what your tags are. So you have to enter them in. So in this case, I put in chemist, lab notebook, and analyst. And see, I pasted them in here in separate lines, said OK. Now when I go and I'll show the user library comment without using tags, you can see that you have your whole comment here. But as soon as you tell it that they are tags, it shows up in a much easier to read format. You can see the chemist has been broken out as a separate entry in the lab and the analyst. So it's a nice way, and anything that's left over that's not a tag will just show up in the comment. So you might want to use tags for your library. It makes it much more professional looking and easier to read because it makes you add things in an orderly manner. The other thing was I wanted to say the inchy key and the estimated retention index are automatically added by the NIST program when you add it to the library. So it calculates an estimated retention index that you can use to compare to other ones that are in the database, and the inchy key for exact structure searches and display. You also have tags for WIley libraries. Really, the WIley library is just a huge user library. So because it's not a NIST library, so NIST will accept it as a user library. They have certain tags that they put in their software that they do when they set it up, and it's Spectrum ID, source, classification, QI, quality index, and splash ID. So you must add those to your display comment field to get them to work. So like I said before, I put in lab notebook, just add these that they have to this list here. You can't see them all because it's a little bit, the window's not big enough to, you have to scroll through it to see them, but I added all the tags shown above. And when you get it now, you'll see that the Wiley database will also show tags with the spectrum ID, the source, the classification, and the quality index and splash ID. And anything that's left over, there's nothing left in their comments because that got everything out of the comment field. You'll notice that all of the spectra from Wiley, or a lot of them that weren't acquired in certain places, will have an index about where they came from, a locator, and that's in the manual. You'll find it on my webpage, and this code will tell you exactly where it came from. If it came from the literature or someone's lab, I find it very useful to know where they came from. But that gives me more confidence depending on where it comes from. And again, I must tell you again, you need to, after you create a new user library or you add a structure or a spectrum to another library, you'll have to re-index some of the capabilities within the library, the indices, to get it to search properly. So always remember to do that. That's a critical step. And again, that was in the tools menu, pull down, rebuild, structure, search databases. And of course, I've mentioned update list of libraries if it's the first time you've used the library, so it'll show the library so you can update the indices. So I want to talk about the use of user libraries at Eastman Chemical Company. We started with the NIST using it as our corporate search system in around 2000. And we used it pretty much at all our locations, our 50 manufacturing sites, anywhere we had a mass spectrometer. And we have about 50 GCMSs and LCMSs networked worldwide. So we have a large group of mass specs that we want to share information between the users so that we don't do duplicate work. And when something's identified in one place, it quickly is reflected at other locations. And so to do this, we created user databases. We have about 60,000 EI spectra in our EI database and about 3,000 in our tandem database. And you say, well, that doesn't sound like a lot of spectra to me. I've got, between my Wiley and my NIST, I have over 1 million structures. So your 60,000 looks a little paltry, doesn't it? Well, yes and no. The 60,000 reflect things that we're very much interested in that are not present in the commercial databases. So in some ways, it's priceless. So I highly recommend, if you use the mass spec and you identify things, you need to put them somewhere so you can retrieve that information, and a user database is a great way to do that. So what do we add to our library? We add anything a user would find useful that's much more diverse than purchased commercial EI and MSMS databases. Thus, the people at Wiley and NIST would not be impressed by some of the things we put in, and it wouldn't be appropriate for their applications because it wouldn't be tied to our manufacturing site. So we can be a little bit more diverse in what we do. But users must realize Eastman databases are an aid to identification and should be used accordingly. You should always look at it skeptically because some things we add in we're not quite so certain about, but they give a lot of useful information about the source, and we'll talk a little bit more about that later in regard to the plant operation. Most entries are high quality, so it must indicate most. We don't put a lot of things with low confidence in it, but we do. But most of them are very high quality with high confidence and an exact structure. Some entries will have a question mark or a double question mark in front of the name to indicate best guess. So the user uses a little caution if we put that. And I've even put 3 question marks to show even less certainty. But still, I want to get an idea there's useful information there that I don't want to lose. I want to capture, but I need to make people aware they should be a little cautious in using that information. Many compounds are added with reference to common names for commercial plasticizers, lubricants, surfactants, etc. And our chemists find that useful, but our engineers find it more useful because engineers don't deal with IUPAC type names of things. They like to use common names. So it's very important to have those. And when you add that synonym, if you do a name search, it'll show up that same spectrum for any of the names that you search. So very, very powerful thing. Many entries are added with reference to plant and R&D processes with known structure, but many include either the molecular formula or accurate mass or the molecular weight by chemical ionization. So if we get that, but we still can't identify it, it's a really good place to archive that information, because one day you might be a little smarter because you know something additional about the sample, and you can use that information that other people have spent obtaining to come to an exact structure in the future. And we just re-add it to the library and take out the old one automatically. So I want to emphasize the importance of library search and comments in the user library. This is our plant at Kingsport, Tennessee. You see it's got a river flowing down the middle. It's actually very close to a community. So we need to be very conscious of our impact of any environmental spills or releases on the environment and on our local neighbors. So we add a lot of things to the library. So we use our LC and GCMS instruments to monitor things, tie them to our carbon analyzers. So if we see something in the river, we know to take a sample, analyze it, and we try to quickly determine the source of the spills in a manufacturing or maybe an air release or breaches from the water treatment plant, et cetera. We want to do that very quickly. And if you put something in the library and you don't know what it is, but you know where it came from. It came from, let's say, plant process 333. If it comes from plant process 333, but I still don't know what it is, as soon as I find out it came from that process, I can see that, well, maybe process 333 occurs in this building on 10th Street, and we know where to go and find the interceptor sewer and the release and stop it immediately. So we add a lot of things to the library that we don't know what they are, but we do tie them with the comments to specific plant processes or R&D processes. Very valuable aspect of having a user library. And of course, the comments are the critical part. If you know where it came from, our environmental people can quickly decide where it's being manufactured at that point in time. So how do you share this database? We have a standard corporate network server system. So just your basic thing, don't pay anything extra for that. We have a lot of users, a lot of MSDs in particular. We also have a limited number of expert mass spec people, but these users can acquire their data and then send the file. If they push the button, don't get the answer, they send it to our experts. They figure out what it is. They send them an annotated file back in email in PDF format, and they add it to the library. So that's the process of looking at something is not completed until the expert adds it to the library such that it'll show up at the user. Every night, the libraries from the expert user are sent to the central share server. It goes to one of the laboratory computers. I think this one goes to the one that runs one of our thermo GCMSs, and it acts as the brains for combining all this thing. And every night, it merges the US user libraries, also takes out things that have been incorrectly added. It'll refresh that too, sends the merged library back to the server, and also puts a timestamp on an archive copy. So if you want to go back a couple of days because you took out something by mistake, it's still there. So that happens automatically. No one does anything. That's been happening for 16 years, every night. And then after that, the user gets it because they drive the get. There's something on their computer that says, get my new library for me. And so in the morning when the user shows up, he has a new copy of the library. So how does this all run? Well, it's pretty much free from NIST. It runs by DOS files written by the user, which was me. And we have a bunch of different DOS files, and it interacts with their lib2NIST program that does all of this combining multiple libraries, et cetera, updating indices, whatever it takes. And the process is managed by an inexpensive Windows scheduling program on the computers. So it just runs these DOS programs automatically, nothing pricey there. And the individual user libraries are automatically merged, distributed, and archived daily. Never fails. Additions and any new entries are available to all users worldwide when they show up for work the next day. So let's look at one of these typical DOS scripts. It looks a little complicated, but I try to do the best I can writing the program. You can see anything with a double dot here is where I've just put in a comment. So I put in a lot of comments about what is it doing, why is it doing things, and then it comes finally down. It makes a couple of guesses. If it exists, it makes sure certain files exist that it needs, and then it just does X copies, and then it also runs different things to lib2NIST. It talks to that utility program to do what it needs to do. And that's pretty much how the whole system works. You just put the scripts on the computer and then you modify them to meet the needs of the specific user. Again, like I said at the first, there's a lot of other things on my website, and they're all related to identifications, one way or the other, to doing unknown identification, problem solving, etc. And if you kind of hover over these in the PDF document, you'll see that it shows where it goes to on the internet. Need to go to that one, sorry. So acknowledgements. I had a lot of help doing this, especially with the webinar production. I really appreciate Brian and Kristen and all the hard work they put in producing this series for me. Technical advice. This goes back, like I say, to 2000. So we had David Sparkman, who's still very active in mass spec, works at NIST, professor at the University of the Pacific. Stephen Stein at the head of NIST. He is a great resource for new ideas, and his talented staff has created lots of new products and we continue to develop improved databases to give to the user. And then the people that work for him, and then even people at Agilent helped me initially. Some of my chemists locally that do some programming helped me, Paul Weiner and John Moore, and then Adam Howard and Kirk Clevin have also helped me be a manager of the library over the years. So Ryan, I think that pretty much wraps it up. Let me look at my list here, but I think I've done everything I want to do. So I think I'll give it back to you for a second.
Thank you, James. On behalf of myself and the rest of the Wiley team, we really want to thank you for the countless hours that you've put into preparing and delivering this series. We truly appreciate it, and I'm sure that those people who are viewing these sessions appreciate it too. And with that being said, I'd like to direct all of our viewers back to the series as a whole. If you had just stumbled upon it during this part 5, this is a 5-part webinar series, and the whole entire series can be found in the resources tab here on your WorkCast screen, on the sciencesolutions.com website /webinars, and on James's website, which is also found on your WorkCast screen under resources under a little mass spec and sailing. On his website, you will also find the handouts that he references and some other helpful resources. Just a reminder that if you have any questions for James, please feel free to ask them in the Ask a Question tab on the right-hand side of your screen, and we could address it via email. One last time, a huge thank you to you, James, and I'll hand it back to you to sign off.
Thank you, Ryan. Thanks for all you've done. I want to make a couple of concluding comments about user libraries. We had a lot of discussions internally about that when we wanted to do that. We were part of Eastman Kodak at that time, and they made the decision that they shouldn't add anything to their library that was not absolutely pristine. And we took a different road at Eastman Chemical Company. We decided we'd add anything that's useful. And you might say, well, that's really dangerous, Jim, that you're going to do that. You might get the wrong answer. And I say yes, I would agree with you. But on the other hand, I think it's much more beneficial to have useful things in there that might get you to the right answer or get you to go down the right path, especially in things that spill into the environment, et cetera. Or you want to save information that you don't fully know what it is, but you spent a lot of time. So you go ahead and put comments, you put it in the library so you let someone else know that you've seen it and what you know, so you don't have to redo that information every time. It's very expensive to acquire the data on the instrument. So you want to capture everything you can that's useful. So we went that path, and we really have not had a problem whatsoever because we're very good about educating our users that this is an aid to interpretation. There are things that might be incorrect in here, but we also tell them there might be things incorrect in the NIST and WIley because we're always finding things in those commercial databases that are not correct. So bottom line, it's such a powerful tool. You push the button, it looks so easy, but you need to be careful. It's a powerful aid to identification, but you as the user need to make sure that the data is good before it's sent out, because if not, you'll lose confidence in to your customer. And so you need to be careful. You need to work with your customers with the sample history, et cetera, to make sure that what you identify makes sense. You might have to buy a sample. You might have to make a sample in a mixture by a known reaction. You don't need to purify it because you got the mass spec, either the GC or the LC, to purify it in a sense. You just need to know if it's a major component by a known reaction. So go out, use the tools, have a good time. I've had fun for the last 42 years, and I don't remember many days that I went to work that I wasn't excited to go to work, because it's such a powerful tool, GCMS and LCMS, for problem solving. So go out, use it, and enjoy it.